Hello and welcome back to the design thinking course that we have. It's been a fantastic last few weeks with you. Now we are going into a very important part of design thinking, a very exciting portion of design thinking. We have looked at two stages so far. First was we got into the shoes of the customer or the user who are you are trying to help. That was the empathize. You got to know them personally, you got to interview them, you got to know what they were going through that you can help out with. The second was analysis, analyze, where we found out with two techniques that we went through with 5 whys, the multi-whys or the why technique. We keep asking a series of whys and we found out what's going on at a root cause level, at different levels, what's going on with the customer. Why is it that they're going through such a problem? Why is it that they are in that state where they need help from people like us? So the next was to see, okay, now that I've found out what is it that is causing that, how can I think about it as a conflict between two parties, two things, a human and a thing, or between two humans. So what is that? Person A wants something and person B wants something else. How do we look at it from this perspective, from this standpoint? From how do we understand both these standpoints? Still, we are helping out one person, but we need to understand the other person's perspective also. So this was what we did so far. So great, we found out what's going on, but we need to solve it. So this is the third phase of design thinking. And we are going to embark on a solution, and this has to address the conflict. So whenever you come up with an idea, you generate an idea, discussing with your friends, discussing it with your colleagues, looking at reading up some material, or you sitting under a tree and waiting for the apple to fall and an idea pops into your head, so be it, grab that idea. The best piece of advice I have for you at this stage is to write it out. To externalize, so that the part of the brain that's working on the idea is a super fast genius who takes things so quickly and rapidly and can help you out with that. That's the guy inside your visual part of the brain, and for that person to get triggered, you need to write things down. Write it on a piece of paper. You don't have to be high tech. You don't have to take the latest gadget and write it down. You can write it on a piece of paper. Even that's great. Okay, so write it down. Write down the ideas. That's the main takeaway from this method, this stage in design thinking. So solve is where we are at. So I'm going to take you to a place far away in time and far away. You probably are living there. I don't know where you're viewing this video from, but the place that we are going to talk about, a story, is set in this place on your screen right now. Can you take a guess where this could be? Quite easy actually, given the way people are dressed in the photo and the way the snow is all around them. There are forests, there are all sorts of like a thick dense forest. Yeah, that's right. You guessed it right. It's Siberia in Russia. So, and the time period around which this photograph was taken was in the 40s. So that's where my story begins, and I would like you to take another guess. Now that you've come with me so far, you've guessed so well where this place is. I'd like you to guess one more thing. What kind of a place are we looking at? Is this a bus stop? Is this a railway station? Is this a port? Is this a frozen lake? What is this? Take a moment to think about what kind of place are we looking at. Okay, any guesses? No, not quite. This is a prison. This is a prison. It doesn't look like it. No high walls, no machine gun bearing down people, soldiers around. Nope, none of them. This is a very unconventional, or this was a very unconventional kind of prison. This was the Gulag Prison, very infamous in the good old days for the fact that it was an extremely torturous place to be in. In fact, the fact that you don't see walls, my guess is that There's nothing for hundreds and hundreds of miles around this place. So even if someone were to escape, there's probably the warmest place that is there for hundreds of miles is the prison. So you're better off in the prison than out there somewhere trying to just survive in this bitter cold. I don't know, minus 40, minus 50 degrees Celsius is not a pleasant condition. So you're better off back in the prison. So my story starts here, circa 40s, 1940s. A young inventor by name Altshuller was imprisoned in this prison. Okay, so let's go to sober times. I mean, this is better times. This is a somber place. So about roll the clock a few years, and young Altshuller was known to be a great inventor. He had filed his first invention way back when he was in his teens. So any problem, anything that he saw, he felt the need to go and invent something, and that's how prolific he was. And particularly when there were resource constraints and things could not be solved. So he's always a very different kind of person. So he started working at a patent office. Patent is a government protection of an idea, similar to a real estate, where you can draw an outline and say this belongs to me or a group of people. Same way this is for the intellectual property, intellectual estate, so to speak. You can actually say this is my idea, and the government says yes, he told me first, he told us first. So this guy gets the patent of that particular idea. So our inventor actually started working in the patent office. He was very excited at this proposition because he was surrounded by people's inventions, people's greatest ideas presented in all its detail. So he actually went through thousands and thousands of paper documents where the patents were written as. So he would go through them page by page, as if he were reading a fiction novel. He would read through patents, and he would really love the whole idea of being there. So he was totally excited by this proposition, and slowly and steadily started realizing that there was something strange going on, that he actually found out certain patterns across these patents. So this was crazy, because the patents that he was looking at reading were from different domains, aerospace and electronics, or whatever was in vogue at the time. I don't know if electronics was around in the 40s, but whatever was in vogue at the time, he saw that there were all commonalities between all these. He noted that there were certain types of problems that were fixed or solved in a certain type of in a certain way. He noticed these patterns all along. And now he was also bothered by the fact, prior to this, is that all the other sciences seemed to have a certain formula, a certain way to do it, except for when it came to problem solving, people relied on intuition and their background and experience, and people who they hung out with, whatever, or their own persona, etc., etc. So nothing about a formula that anybody could learn up and actually solve, like you have in mathematics or chemistry, for example. These two rely on formulae to get you going, right? The same way. So if I knew a formula to invent, to solve a particular problem, I could actually teach anybody, and they could actually get faster with this, get better at problem solving as well. So he was really enamored by this. So that suddenly popped up, and I said, hey, wait a second, this sounds like a formula. This sounds like a way to solve it, a very systematic way to solve it. And he slowly started categorizing the problems and the solutions accordingly. So he did that very methodically with thousands and thousands of these patents, and finally figured out that a way, an algorithm or a formula to actually solve the problem. And he was happy about it, and he said, this is great, this is he was extremely excited about this idea, and he said, the whole nation has to know about this. All the schools have to know about this. They have to start doing it. They have to start embarking on this method. And what he did was he wrote a big long letter to the then president of, or the story goes from the internet, I'm borrowing this from a story on the internet, that he actually wrote a letter to Joseph Stalin, the president or the head of state for the USSR at the time, and he said this is what we can do to take our motherland to greater heights. So he wrote all that, and he did not hear back from Joseph Stalin. Of course, he is the head of the state, he's a busy guy, he doesn't reply to every mail that comes to him, right? So a year later, Altshuller did get his reply, and I'm guessing it was in the middle of the night, somebody knocking on the door, is this Altshuller? And then this guy is sleepily opening the door, and Altshuller saying, yes, this is me, and they say, you're under arrest. What? Why am I under arrest? And they say, well, you wrote this long letter? Yes. Oh, then you're under arrest. So it turns out that he not only wrote about how to transform the motherland into greater heights by using this method, but in the way he had also sort of put down the way things were run in the state at the time, and that probably didn't go very well with Joseph Stalin, and that's why he ended up in the place that you see on the screen, Siberia, Gulag Prison. So Altshuller should have been totally crestfallen. His mom didn't think he would come back at all, because people who went there never returned. So this was a pretty sad state at the time. But Altshuller was extremely motivated. He said, wow, this is a great place for me to think about this. There is hard day's labor, and he has to do all those things that they do in the prison, but he still had time to think. His brain was free to think about stuff, about invention, about problem solving. And then he felt the need for going and checking with people as to how does this fare in other domains like mathematics and biology and chemistry and all these. He wanted to check with other people, and this was a prison. I mean, how could he find such people? But he was wrong. There were other people who were biologists, chemists, physicists. All these guys were there in prison because of some political something that they had done. So they're all there, and he would go and check with them that is this really working out very well? Is this theory, does this make sense for your domain? And he got a few suggestions, he perfected the theory. So he worked on this in his spare time in the prison, and 5 years later, the prison's period was 5 years, about 5 years, and at the end of 5 years, Joseph Stalin passed away, and they started releasing political prisoners from the Joseph Stalin regime, and Altshuller was one of them. So he was released. He was happy to be out in the free world. So now he was totally motivated to go and check out how his theory will stand. So he started running case study after case study. So this is his picture. This is generic Altshuller. He came up with this idea that problem solving can actually be a formula, and he applied it and started applying for different case studies in real life. He's developed an algorithm of problem solving. He called it TRIZ, is the Russian acronym for algorithm of inventive problem solving, and he slowly started releasing version after version. He tried it several case studies. He would painstakingly take so many years to make small changes to his algorithm. So in his own words, he says that this algorithm is great on its own. It works on its own because he had tried it on so many case studies. But he said this can be a great aid to inventors. It can be like a ladder guiding them. Okay, if you shouldn't go too far away from this, but you can actually go towards a certain path. So that was what he set out to do. So this is in Russian. The Russian pronunciation, if I get it right, is Teoriya, Resheniya, Izobretatelskikh, Zadatch. And the acronym for that is TRIZ. This is the theory that he pulled out of the algorithm after trying it so many times. He actually he built the whole theory around this, and even sought to find out how the human mind works, how the whole creative skill works, and it's now popularly known as TRIZ, TRIZ. The Russian acronym still stays. In between, some people did try to call it TIPS, as Theory of Inventive Problem Solving, TIPS. But for a powerful method like for inventive problem solving, TIPS sounded more like pocket change than a powerful theory. So TRIZ still sticks. You can find lots of literature in this method, in this theory, all across the internet. I have given you a few references as well in the reference list. So this is the theory that Altshuller came, and this generated, and now lots of people across the globe, even including Altshuller students, have taken the message all across and have really made a difference in many industries, made inventors' jobs a little easier, and generated a lot of ideas using TRIZ as a method. So why am I telling you this? Because this is an efficient way of solving a problem. You don't have to try out all sorts of variants before generating the method that works. So this is why I am introducing you to this method. To continue and finish up the story, Altshuller wrote many books in Russian. Few of them were translated to English. One of my favorites is this book called Innovation Algorithm, and here he gives a lot of examples on how to invent particularly, doing it systematically. And this is in technical field because Altshuller himself was a mechanical engineer. The terms that were used were all to do with mechanical engineering, but this applies, after so many years we found that this applies all across disciplines. Okay. One of the methods that he suggested, and a very powerful one at that, is one of the components is after you do your conflict analysis, which we did last time, you can actually use one of the methods called Inventive Principles. What it says is that, like I was talking to you about, certain methods, certain types of solutions, these were crystallized, they were put into heuristics of saying, I will give you some examples of how these things are worded, and you can actually apply it back to your problem and generate ideas so that your conflict is resolved. So that, between two humans or between a human and a thing, you can actually resolve the conflict. So this is what Altshuller had said. One of the algorithm looks like this. So many steps, and it asks you certain questions. You need, it's almost like a form to fill out, but you need to keep doing the thinking. The thinking is not replaced by the method. The thinking is still done by the human. So oftentimes they get this question from students. So should I tone down my thinking and just follow this and I should be okay? No, you still have to do the thinking. You still have to do the finding. It's still the inventor's job to solve the problem. This guides you in your thinking. So worry not. I'm straitjacketing you and saying this is the only way to think, this is the only way to go. If you're stuck, if you cannot move, what is the equivalent of a writer's block for an author, for a writer, is an inventor's block. If you've reached that, then this method will help you. That's what I'm telling you. So this is a snapshot from the book. I promised to give you examples of inventive principles. This is one of the inventive principles called preliminary action. So what it says is that perform before it is needed the required change of an object, either fully or partially. An example is given for you. It is to sterilize all instruments needed for a surgical procedure on a sealed tray. So before the surgery is performed, all of this the instruments needed are all sterilized and kept on a sealed tray so that it's ready when the surgery has to be performed in the state that the surgeon wants it to be. So another example or another way to do preliminary action is prearrange objects such that they can come into action from the most convenient place and without losing time for their delivery. This is popularly known as just in time. In some factories have this implemented. So there's no need for a warehouse. The components come on time, just in time, and get delivered when it's needed. Not before, not after, but just in time. So this is one of the manifestations of preliminary action. So this is the number 10 in this signifies that it's the number 10 principle, There are 40 principles that Altshuller thought about, saw this in the patents. He also generated 76 standard solutions that also became popular. But 40 is easier to work with, easier to imagine. 76 requires a little bit of training for you to think about it, how do you apply it, and if you have it nailed down, the problem nailed down, then 76 standard solutions help you. In this course, we are not going to go deeper into this. I'm going to give you 2 more examples, and then we will move on to the solve part of it. So, in here the next principle is beforehand cushioning. The example is a backup parachute. So, you need something to compensate for the relatively low reliability of an object, then you do this. So, this one is my favorite, one of my favorites of the principle number 13, the other way round. In here, we do the opposite to solve a problem. So, if you have a stuck part, rather than cooling the inner part, we heat the outer part to loosen it out. So, this is an other way round. A treadmill is an excellent example of making movable parts fixed and fixed parts movable. So, the jogger is in place while the path is moving. Typically, a jogger moves and the path remains stationary. In a treadmill, it is the opposite. So, these are several ways to do this. So, other way round is a principle, name of a principle. Now that you have identified the conflict, can I flip the actors around? Can I flip whatever is moving stationary, and can I change the other one around? So, these are questions you should be asking to generate ideas. Okay. So, let us look at some of the examples we looked at last time. This is my first problem that I proposed to you. I said you should be thinking about this. So, if you remember, I will reiterate the problem right here we are looking at is this distracted child. I mean, he is not just one of them, there are probably many of them, but this guy clearly is distracted. He is looking at something else, and he is not paying attention to what the teacher is saying. But I am sure the class is filled with people who have different learning rates. So, that is the problem that I had posed to you. So, now you had what you had to do was to analyze using 5 whys and the conflict of interest. Once you have that, then we can jump into the solved stage. So, I am going to help you out with that. I am going to give out some of the answers here. Let us go to the blackboard. So, the teacher is teaching and this guy is not paying attention. So, let us say, why is he distracted? So, why is he distracted? Well, he is learning at a slow pace, the teacher has already gone past, he is not able to keep in pace with what the teacher is saying. So, this is the reason is she is teaching very fast. The teacher in our picture was teaching very fast. So, we had a fast teacher, fast teaching teacher. So, why is she going fast? Why is the teacher in our picture going very fast? Well, she has lot of syllabus to cover, lot of syllabus to cover. Okay. So, let us say a large portion of syllabus still remains and she is not able to cover, that is why she is going fast, and since the kid cannot keep up, the kid is distracted. Why does she have a lot of syllabus to cover? Well, she has been assigned that this is what the diktat of the government is. So, let us say she is following a government syllabus. So, that is fixed. So, we have reached a place where unless you work for the government and you can make a difference, you should probably look at this level. For simplicity's sake, I am going to look at this level, which is distracted versus fast teacher. And why does the teacher teach very fast? It's a lot of things to cover. I am saying a lot of syllabus, but it's a lot of portion to cover in the syllabus. So, if we look at it one more time in terms of a plot, if you remember from my last time, we had plots for plotting the 5 why analysis. So, how do we track the performance of the child? Let us call it learning retention. So, how much does the child actually retain? Okay. So, high point and the low point. So, the high point is high learning retention. So, if the child is able to recall or able to retain a lot of information in a lot of what the teacher is saying, in this class, say it is a beginner class, we will keep that as high, and low is the opposite, which is the kid is not able to catch up with class, what is going on. And the variable that we have with us is the pace of teaching. Pace of teaching. Sorry, this is pace. Okay, so now if we look at this plot, we have a high learning retention, and the pace of teaching is what we are tracking. So we have a low pace of teaching, which means she is going very slow. Let's say it's slow, and she's going very fast. So that's the variable the teacher has. From a teacher's point of view, the one thing that she can vary to keep the child interested and keep motivated and make him or her retain. In our case, it's a him, I guess, the student. We will make him retain. We need to track that. So that's our variable that we are tracking. If you remember from last class, we actually had a plot like this, a straight line, just to keep things simple. If I go fast, if I'm the teacher and I go very fast, I sort of miss out on the retention. This kid is probably not retaining a whole lot, and hence he is distracted. But if I choose to go slow, I will have a high retention. However, what I am losing out on is, here's the conflict, is that I will not be able to cover my syllabus if I am the teacher. Okay. So this is what the teacher can control, whether I can go fast or whether I can go slow. What's the parameter that we are losing out on if we go very slow is the extent of syllabus, let's say the extent of syllabus coverage. Okay. So the extent of syllabus is what we will miss out on. So if we actually go slow in teaching, we are going to miss out on the extent of syllabus. It's going to remain uncovered. If you go fast, syllabus is covered, great, but I lose out on my primary customer, who is my student. Now that I've presented it this way, it started to sound like a conflict, right? So remember the conflict of interest. Now the conflict is between the teacher and the student. So that's what we are looking at from on these x and y. So now we will look at the conflict itself. So here's the teacher and the syllabus, let's put it that way. And sorry about the bad handwriting here. I drew a small box, and that was the problem. Here we have is, what can I vary? It's the pace of teaching. Okay. So it's pace of teaching. I can choose to go fast, I can choose to go very fast or fast, and I can choose to go slow. Okay. So these are the two states, so to speak, between slow and fast. And then what happens as a result of going slow and fast? So represented like what we had last time is, when I go fast, I lose out on retention from the student. So student retention is low. Let me abbreviate it. Retention is low. So I put a down arrow so that I indicate to you it's slow. Whereas what I am gaining out of going very fast is covered syllabus. So I have actually done a good job in the administration's eyes. I have actually covered it on time. If I go slow, yay for the student. Student actually loves me because I am matching pace with his learning speed. So student retention is definitely there, it's a high. And what I am losing out on is uncovered syllabus. I have not finished what I have signed up for. So I have a lot of stuff that I haven't covered. So as design thinkers, what we generally need are these two, which is the covered syllabus and student retention to be very high. So this is my desired result. Okay. So I will post it in a better way. This is how I am writing on my blackboard here. So this is what is going on with respect to the analysis of the teacher student problem. Okay. So this is a conflict of interest between the student and the teacher. Now how do I solve this problem of, I want to be fast so that I can cover my syllabus, but I have to be slow so that the student retains it? And if you remember, one of the principles I said was going the other way around. I'll give you a moment to think about what can you do other way around, opposite of course you can come out with your own ideas, but I'm just trying to help you here using what we just learned a few minutes ago, is how do I help my student retain, and how do I help my teacher teach at a fast rate, teach so that she covers her syllabus. So this is the conflict of interest we had, and I'm asking you to apply the other way around idea to see how you can solve this. A moment here, you can pause the video if you want. Any ideas? Okay, yeah. So the most common idea that normally I hear from my students is, let's make the student a teacher and the teacher reverses the role. So she cuts up a portion of the syllabus and gives it to the students. This is a common practice in some subjects. Some brave teachers do this and says, you guys prepare and tell me what you've learned, and you will have to present and teach the other people in the class. So this way there is a role reversal, and actually the students end up retaining a lot more than what the teacher could possibly imagine. And you can be selective, saying this guy can do this job and that guy can do that job. So you can actually do that. So this is a reversal idea. Of course, there are several other ideas that can keep coming up. Like for example, the preparatory work, you saw prior action. You can actually ask them to prepare in advance and come here to clear their doubts in hand. Or you could do a video recording and make them play it at home, like you've seen popular platforms like this. Even like this, you can actually slow down, go reverse and see what I've spoken a few minutes ago. This is also an example of reversal. I come to your home through a medium rather than you coming to my class and listening to me at whatever pace I have to teach. So this is a reversal as well. So several ways to solve this problem. This is just a trigger to get you thinking about how to apply these methods that I talked about. The same way you can do the analysis of this aircraft landing, a lot of smoke. So the conflict really is between the tire and the runway, and there's a lot of puff of smoke that you can see, and that is because there's a tire wear. At the moment the tire actually hits the surface, and you can actually solve this by applying a reverse. Once you've figured out what the problem is that it's too fast at that particular time. That is the conflict. You want the wheels to be slow so that it does not wear the tires, and it has to be fast so it can land. There is a case of aerodynamic stalls if it goes too slow, these conventional aircrafts, including this space shuttle. So you need to be fast so that it can land. You need to be slow so that there is tire wear. And the way to reverse, you can reverse it. Some of my students think of ideas like, oh well, I'll make a conveyor belt that is at the same speed as the aircraft. I will dump a lot of tires, spent tires already at the place where the runways, or rubberize the place where the runway is. One oftentimes I've read the solution that I've seen for this is the other way around solution, is to rotate the tire at the same speed as the aircraft. So the relative speed between the ground and the wheels are zero. So it's as if it's landing stationary. So it doesn't actually start from 0 to 200 at 200 kilometer, whatever speed it is going at that moment, but it's already at a rotating speed, so the tire wear is minimal. So this is one solution from the other way around principle. The third problem that we looked at last time, again you can do the analysis similar to that, is the chocolates are melting when you take it to a hot place, and that was the main problem. So you need the chocolates to be in solid shape with the customer, with somebody who is opening it, and you want it to be transported in hot places. So the conflict is between the environment and the chocolate. So the other way around solution can be applied here, and can I, instead of heating the environment, which is what the air conditioning will do, can you think of lower cost ways to do it? Well, we will cool the chocolate before it's shipped, to ultra low temperatures and then ship it with vacuum around it. You can probably pull out the air and send it across. So it's at a cooler environment all through its shipping, and at the end you get is a cool chocolate. So we have done the other way around, not by allowing it to heat up, but to cool it prior. So this is a prior action, sorry. Previously you do this, and so you solve the problem. So many ways to solve this. Of course, we have not submitted these ideas to Hershey's. If you want to, and probably Hershey's already figured out how to do this. So again, like I said last time, this was an open innovation problem that we found. So you can take up more problems that you see all around you, apply the multi-why, apply conflict of interest, and take one of these principles and see if how it works, just to get practice on that before you can embark on serious problems. So that's it for now, this module of solve. So I would like you to go out in the world and try these methods with the examples that we have suggested in this part of this course, so that you can actually get more practice. This is about just like driving or swimming or new skills that you've learned. This is about trying it many times, and then you get you attain mastery with these methods. Okay, so happy luck, good luck trying these methods. Bye bye.